Now we're going to revisit an idea, and that is the idea of empirical and molecular formulas. So remember that the empirical formula is the lowest whole number ratio for atoms in a formula, okay? And so the lowest whole number ratio that can be achieved for those particular atoms. And so consider this example problem here. It says during excessive activity, lactic acid, and it's giving you a molar mass, the big MM stands for molar mass of 90.08 grams per mole, forms in muscle tissue and responsible for muscle soreness. Elemental analysis shows that the compound is composed of carbon, 40.0%, hydrogen, 6.71%, and oxygen, 53.3%. Find the empirical formula of lactic acid. If you ever get a problem like this, these are the steps you should take to actually calculate the empirical formula. The first step is to actually assume that you have 100 grams of the substance, so 100 grams of this lactic acid. And then you convert, and then you take the percentages of each of those individuals and convert that into grams. So if you have 40.0% carbon and you have 100 grams of the substance, how many grams of carbon do you have? The answer is 40. Whoops. The answer is 40.0 grams of carbon. Do the same thing with hydrogen, 6.71 grams of hydrogen, and the same thing with the oxygen, so 53.3 grams of oxygen. Then you divide each of those numbers by the molar mass for that particular element. So going back to our periodic table, which is right here, carbon is found right here, so it's 12.0. We need to keep the same number of significant figures, at least the same number, so 12.0 grams per unit, okay, per mole. So if we have 40.0 grams of carbon and we have 12.0 grams per mole, that means we would have a certain number of carbon atoms. Let's set up all of them so I can bring up the calculator at one time. So 6.71 grams of hydrogen. Going back to our periodic table, we see it's 1.0 moles. We'll keep 3 sig figs. So 1.01 grams per mole divided by 1.01 grams per mole. And then finally for oxygen, 53.3 grams of oxygen divided by the molar mass of oxygen, which is 16.00 grams per mole, 16.00 grams per mole. Notice what our units will be. Remember, this is in the denominator of a denominator, so it'll be numerator. The grams will cancel, so we'll just have units of moles. So bringing up the calculator here, 40.0 divided by 12.0 to 3 sig figs would be 3.33. So let's go ahead and write that down, 3.33 mole of carbon. And go, 6.71 divided by 1.01 would be 6.64 moles of hydrogen. So equals 6.64 mole of hydrogen. And then finally down here, we put in 53.3 divided by 16 would be 3.33 mole of oxygen. Now then go into the next step. So you divide each number by the smallest number of moles to find the molar ratio. Well, if you look back here, these are both 3.33. So we put 3.33 mole of carbon divided by 3.33 is equal to 1 mole of carbon. Then we do the same thing for hydrogen. What was it? It was 6.64, so 6.64 mole of hydrogen divided by 3.33. And that's essential. Oh, well, let me actually bring that up so you guys can see it. 6.64 divided by 3.33. Look at that, 1.99. So 1.99 mole of hydrogen, and then again 3.33 mole of oxygen divided by 3.33 is 1.00 moles of oxygen. So now you round these numbers to the nearest whole number. This of course will round to 2. These are already at their whole numbers, and you use those for the subscripts for your empirical formula. So carbon, there would be 1 in the subscript. Hydrogen, there would be a 2, round that to 2. And oxygen, you would round that to 1. So this is the empirical formula for our compound. So now that we have our empirical formula for our compound, let's go ahead and look at how you would calculate a molecular formula from an empirical formula. So just recall that a molecular formula is essentially the lowest whole number ratio the empirical formula is the lowest whole number ratio for the molecular formula. So notice these are evenly divisible by 6, and so 6 divided by 6 is 1, 6 divided by 6 is 1, so this is the difference between the molecular and empirical formula. So these are the steps you take. So to find the molecular formula from an empirical formula and a molecular weight, you calculate the formula weight for the empirical formula. That's what we just did for that last one. Let me go back. So this would be the empirical formula we calculated. Then you divide the molecular weight by by the empirical formula weight. So what would the empirical formula weight be? And then you multiply all subscripts by the results. So going back to our example, this is just a general example, but going back to our example, we see that we're given the formula weight here, okay? So it's 90.08 grams per mole. This is the empirical formula that we calculated. So what would the molecular weight be of that particular molecule? Okay, so going back to the periodic table. Going back to the periodic table. Where's my periodic table? We see that carbon's 12.01. There, I'll 12.01. Check your periodic table if you don't believe me about this. Hydrogen's 1.01 to 2 sig figs. Oxygen is 16.00. But we have 2 hydrogens, right? So we need to multiply that by 2. So it's 12.01, 2.02, and 16.00. Add these together, we get 30. Point, and that would be 0, and then we put a 1 here, so it'd be 30.03. That would be grams per mole, right? So grams per mole for the formula weight here. Now we would take this 90.08 grams per mole divided by 30.03 grams per mole. Get out the calculator again. I'll bet you can guess what it's going to be, but let's put it in just to show it. Divided by 30.03. And look, that's essentially equal to 3 sig figs is actually 3.000. So this is equal to 3.000. So what we do is, which is essentially just 3. So what we do is we multiply each one of these subscripts by the 3. So 3 times 1 would be 3. 3 times 2 would be 6. And then 3 times 1 would again be 3. And so this is the molecular formula for that empirical formula. All right. So that is how you would calculate those those different molecular and empirical formulas with the information given.